In this lesson, we want to learn about multiplying matrices. All right, so in our last lesson, we learned about multiplying a matrix by a scalar. Again, a scalar is just a real number that's not inside of a matrix. And we found that that process was extremely straightforward, right? You just took the scalar and multiplied it by every entry of your matrix to get your result. When you multiply two matrices together, however, the process is not so straightforward. It's not what you would expect, okay? And so what we want to do is just kind of start out with a very basic, very easy example, and then just build up to the kind of tougher examples that you're going to get for your test or your homework or whatever you are encountering. So let's say we have these two matrices here. We have R, which is a row matrix. It's got one single row with 3, -2, and 5 as its elements. Again, you could call this a row vector if you wanted to. Then C is going to be one single column with -1, 0, and -3. So you could say this is a column matrix or a column vector. So what we want to start out with is finding the product of R times C. So what is R times C? So I can write these two next to each other like this, or I can put a dot in between them. It doesn't really matter. So what I want to do first is just write out the size of each. Okay, this is going to be very important. So I'm going to say that R is a 1 by 3. It's got one row and it's got 3 columns. And I'm going to say that C is what? It's a 3 by 1. It's a 3 by 1. Now, this is very important. This is something you want to write down. You can only perform the multiplication if the number of columns in the first matrix, meaning the leftmost matrix, the R here, matches the number of rows in the second matrix or the rightmost matrix, the C here. So you can just circle these two inside numbers if you write it in this manner, and you can say, are they the same? And if they're the same, you can put a check mark there and say, okay, I can proceed with my multiplication. If those two guys are not the same, you have to stop. The multiplication is not going to be possible. Okay, so you can say the product doesn't exist. Now, the second thing you want to do here is figure out the size of the product. And the way you're going to get that is you're going to look at these two outside numbers. So you have this, the number of rows from R, and this, the number of columns, okay, from C. So this matrix will be a 1 by 1. Okay, so this will be a 1 by 1. So once I determine if I can perform the action, and then I determine what the size of the product is, I go ahead and write out my matrix. I know it's a 1 by 1, so it's just a matrix with one single entry. And at this point, I can erase all this. I don't need it anymore. And then I'm going to go through a process that might seem a little bit weird at first, but it gets easier as you kind of do it. So what I'm going to do is I'm going to think about the first element in this R. This first one right here, the first element in R, or the leftmost one, is a 3, okay? What I'm going to do is I'm going to multiply it by the top element, or I could say the first element in C, okay? So this guy right here gets multiplied by this guy right here. So 3 times -1, all right? Then you're going to add to this. You're going to move down by 1, and you're going to move down by 1. So now what I'm going to do is I'm going to do -2 times 0. Okay, so -2 times 0. And then I'm going to add to this. I'm going to do this trick one more time. I'm going to move down, and I'm going to move down. So 5 times -3, so 5 times -3. I'm going to find this kind of result, and that's going to be what I'm going to put in there. Okay, and this might not make any sense at this point. That's okay. As we practice, we'll start to see what's going on here. So 3 times -1 is -3. Plus -2 times 0 is obviously 0. Then plus 5 times -3 is -15. So -3 plus -15 would be -18. So that is going to be the result of R times C. Okay, and we're going to find that we're going to need to do a row vector times a column vector pretty often. So we need to make sure we understand what we did there. Again, we would start with this guy right here from this one times this guy right here from this one. Okay, then we would add to that this guy right here times this guy right here. Then we add to that this guy right here times this guy right here. Okay, so now that we have that down, what we want to do is move on to kind of something else. We know that when we talk about multiplication with real numbers, it's commutative. If I do 3 times 2, it's 6. If I do 2 times 3, it's also 6. 3 times 2 equals 6. And then 2 times 3 also equals 6. This is the commutative property of multiplication. With kind of multiplying matrices, it's not commutative. Okay, so when you flip the order, generally speaking, you're not going to get the same answer. And sometimes you're going to find that you can't even do the multiplication. Okay, so what happens if we change the order here? What if we did C times R? Well, again, let's kind of write this out and compare our size. C is what? It's a 1, 2, 3 row by 1 column matrix, and R is a 1 row by 3 column matrix. Okay, so now again we're comparing the inside numbers. The number of columns from C, the first one, has to be equal to the number of rows from R, the second one. Okay, so those match. These are the same. Again, if they're the same, you can put a check mark and say, okay, I can proceed. Then the size of this guy is going to be given by the outer numbers. So it's a 3 by 3, 3 rows by 3 columns. So let's erase this. And let me kind of slide this down a little bit. So we have C times R here, and this is going to be a 3 by 3. So I always write this out first. Now, here's where it gets a little bit tricky, okay? I want to write this out so you understand what's going on. This is row 1, this is row 2, this is row 3. This is column 1, column 2, and column 3, okay? So what I want to do here, if I want to find this entry here, I want to think about, okay, it's in row 1, column 1. All right, row 1, column 1. So what I'm going to do is I'm going to multiply row 1 from the left one, or C, times column 1 from the right one, or R. Or you could say row 1 from the first one, or C, times column 1 from the second one, or R. However you want to think about that. So row 1 in C is this guy right here. And column 1 in R is this guy right here. Again, because we have such a simple example, it's just going to be, 3 times -1 in this case. As we get to the tougher ones, then you're going to have to go through what we did before, where you're finding a couple of different products and summing them together. But here it's very simple. So it's just 3 times -1, which is -3. Okay, so that's this guy right here. Then we move down to this one. Okay, so now I have my row 1 and column 2. Okay, so I'm basically going to stay with this one. Because again, when I think about the row, it comes from the leftmost one. It comes from C. It comes from the first one. You've got to remember that. So I stay here. I'm still in my row 1 here, but I'm now moving to column 2 here. So I'm moving down. So -1 times -2 is 2, okay? And then again, if I'm staying in row 1 here, okay, I'm staying in row 1 here, I'm just moving down to column 3 here. So I would have -1 times 5, which is -5. Okay, and if this is not kind of gelling right now, it's okay. As we work through more examples, you'll start to pick this up. Now, I'm moving into row 2 here in my answer. So what I want to do is move to row 2, again, in C, because I'm always getting my row from the leftmost one. So I'm in row 2 now here, and I'm going to multiply to get this whole row by column 1 to get this one, by column 2 to get this one, by column 3 to get this one. Again, because I have column 1, column 2, column 3. That's all I'm doing. Now, because 0 multiplied by anything is 0, this whole row is going to be 0. 0 times 3 is 0. 0 times -2 is 0. 0 times 5 is 0. Then, when I get to row 3 down here, again, I just changed the row I'm in for this first one. So now I'm here, okay? So row 3, column 1. -3 times this guy in column 1, so times 3, it's going to be -9. Then -3 times this guy in column 2 is going to be -2. So -3 times -2 is 6. Then -3 times this guy in column 3, which is 5, is going to be -15. Okay, so that's how we get the entries. As we get into a tougher example in a minute, you'll see that you have more work involved, but the process is basically the same. Okay, so you see that R times C is -18. That one entry for that matrix, and C times R is not the same, right? They're not equal to each other. Completely different size. This guy has -3, 2, -5, 0, 0, 0, and -9, 6, and -15 as its entries. All right, so let's go ahead and look at a tougher example now. So suppose we have matrix A and matrix B. So for matrix A, we have 2 rows and 1, 2, 3 columns. So A, I'm going to write my size down. It's 2 by 3. And then for B, it's what? It's 1, 2, 3 rows, okay, by 1, 2, 3, 4 columns. So can we find the product of A times B? Again, you're looking at the inside numbers, the columns from A, the first one, and the rows from B, the second one. So do these numbers match here? Yeah, they're the same, okay? So we know we're good to go, and let me make that a little bit better. We know we're good to go on the multiplication here. Now, if I flip the order of the multiplication, if I said, can I do b times a, you're not going to be able to. Because if I kind of change this up, and I said that, let me just kind of drag this over here, and let me drag them both over here so they fit. So if I look at this now, the two inside numbers do not match. Okay, and this is very surprising, again, not being able to use this kind of commutative property that we're used to. If we do a times b, the product exists. If we do b times a, the product does not exist. Okay, so we want to go back to a times b. That's what we're going to be working with. So let me just kind of slide this back over. And let me just kind of slide this back over. So we want to find a times b. Again, we know that these numbers are the same, so it works. And we know that this guy is going to be a 2 by 4 matrix, okay? So the very first thing we're going to do is set up our matrix. It's a 2 by 4. So AB is equal to, okay? And let me write this out. So 1, 2, 3, 4 entries. 1, 2, 3, 4 entries. And another thing that I'm going to do, I did this before. I'm just going to put the columns, the numbers in there just so we can keep track of what's going on. This is something that really helps the students that I've tutored in the past just to keep track of where they are, okay? Because a lot of times they go to a specific entry and they go, I don't know what to do, or they forget stuff, or they kind of jumble it up. This tells me immediately that what? I'm in row 1, column 1. So where do I get that from? Again, the row always comes from the first one, the leftmost one. Just remember that. The column comes from the second one or the rightmost one. So I'm just going to start in row 1 in A. And I'm going to highlight that or circle it or whatever you want to do. Just, you're going to work with that for this entire row all the way across. And all you're going to do is you're going to just keep going through the column. So you're going to go this one times this one, then this one times this one, then times this one, then times this one. That's going to give you your whole first row, okay? So for this first entry here, I'm doing this top row times this first column. Row 1, column 1, row 1, column 1. That's all it is. Remember, when you do this, we have to go through the corresponding entries. So you have the first one here and the first one here. So 2 times 9, that's 18. Then plus, you have this guy here, which is the second one, times this guy here. 3 times 10 is 30. Then plus, you have the third one here times the third one here. 0 times 1 is 0. So 18 plus 30 is 48, plus 0 is still 48, okay? So it's not that bad overall, but it does get, you know, a little bit tedious, especially if you have something that's kind of bigger in nature. So let's erase this and move down to this one. So I'm still in the first row. I'm just going to the second column now, okay? So let me highlight that. We're going to do 2 times 2, which is 4, plus 3 times 5, which is 15, plus 0 times 0 is obviously 0, so you can just leave that off. 4 plus 15 is going to be 19. Okay, so that's how we get that one there. And again, we just move down. So now I'm going to be in row 1, column 3. So row 1, column 3. Okay, so 2 times 0 is 0, plus 3 times negative 2 is negative 6, and then 0 times 7 is 0, so this is just negative 6. So pretty easy. And let's erase this. And let's go into this kind of last column here. So we're going to say that we have 2 times negative 4, which is negative 8, plus 3 times 20, which is 60, and then plus, we know 0 times anything is 0, so we don't need to worry about that. And negative 8 plus 60 is going to be positive 52. So we've got the first row worked out, okay? So now what I'm going to do, since I'm going to row 2 in the answer, I'm going to move down to row 2 here. Again, the row comes from the first matrix. Just remember that, okay? So my first matrix is A, so I'm just going to highlight that, and then I'm going to work column by column, okay? That's all I'm going to do. So I'm going to say, okay, I've got this row times this first column to give me this guy right here. So we do negative 1 times 9, that's negative 9, plus 5 times 10, that's 50, plus 11 times 1, that's 11. So 50 plus 11 is 61, and then minus 9 is going to give me 52. Okay, so this is 52. Okay, so let's erase this. And again, I'm just shifting 1 over. I'm going into column 2 and B because I'm in column 2 here. Okay, so you've got negative 1 times 2, which is negative 2, plus 5 times 5 is 25, and 11 times 0 is 0. So negative 2 plus 25 is 23. Okay, and again, I'm just shifting down, so now I'm in this column. And so negative 1 times 0 is 0, plus you've got 5 times negative 2, which is negative 10, plus you've got 11 times 7, which is 77. 77 plus negative 10 is 67. Okay, and then we have one more. So we have this column here. So we have negative 1 times negative 4, which is 4, 5 times 20, which is 100, And then we have 11 times 11, which is 121. So if I sum all these together, I know 4 plus 121 is 125. 125 plus 100 is 225. So there we go. We found our product AB. Okay, not so bad. Again, I recommend writing this stuff in so you can figure out where you are. Row 1, row 2, column 1, column 2, column 3, column 4. Again, if I'm wanting this entry here, I find row 1 times column 1. Okay, I always find the row from the left one and the column from the right one. Okay, or you could say the first and the second one, however you want to define that. Once you do this a few times, it becomes very, very simple. All right, let's go ahead and do another one. Again, this is one where you need a lot of practice. So we have matrix A and matrix B. So first and foremost, let's try AB. So AB, the size of A, it's a 1, 2 by 1, 2, 3. So it's a 2 by 3. The size of B is a 1, 2, 3, okay, by a 1, 2. So again, if these numbers match up, you are good to go. You can put a check and say, yes, we can go ahead and do it. And the size of the product comes from these outside numbers. So it's going to be a 2 by 2 matrix, okay? So I'm going to go ahead and set that up. I'm going to say AB is equal to, again, it's a 2 by 2. So just draw this out. You've got 4 entries to fill out, okay? And again, this should help you when you start. This is row 1, row 2, this is column 1 and column 2. So how do I get this entry? Again. I get my row from the first one, the leftmost one, however you want to think about that. It's coming from A. So I'm just going to highlight this row here, okay? That's where I'm going to be for here and here. And then I'm just going to go through. If I want row 1, column 1, I want row 1 times this column here, column 1 in B. So again, we go through and figure this out. Negative 2 times 1 is negative 2. Plus you've got 0 times 2, which is 0. Plus you've got 1 times 0, which is 0. So this is just going to be negative 2, okay? Then I'm going to slide down because I'm now in row 1, okay? Stay in row 1, but I'm in column 2. So row 1 here times column 2 here. So that's going to be what? It's going to be negative 2 times 5, which is negative 10, plus 0 times negative 3, which is 0, plus 1 times 7, which is 7. This would give me negative 10 plus 7 is negative 3. Okay, so let's move on now. So we're in row 2. So again, now I'm going to shift from this row 1 down here to row 2. Okay, so since I'm starting here and it's in column 1, I'm going to multiply this row by this column. Okay, so I'm going to have 5 times 1, which is 5, plus 9 times 2, which is 18, plus negative 5 times 0, which is 0. 5 plus 18 is going to be 23. Okay, 23. And then lastly, what I want to do is this row times this column right here. 5 times 5 is 25, plus 9 times negative 3 is negative 27. And then plus, you've got negative 5 times 7, which is negative 35. So let's figure out what this is going to be. Well, I know that 25 plus negative 27 is going to be negative 2. So basically, I would have negative 2 plus negative 35, and that's going to be negative 37. Okay, so negative 37. So not that bad overall. We found that our entries here are negative 2, negative 3, 23, and negative 37. All right, so let's erase this, and then let's figure out if we can do B times A. So B times A. The size of B, again, is a 3 by 2. And the size of A is going to be a what? It's a 2 by 3. So 2 here and 2 here. The columns from B, the first one, match the rows from A, the second one. So we are good to go. Okay, so we can do this multiplication. The size of the product is going to be the outer numbers, so 3 by 3. So BA is going to be this 3 by 3. So I'm going to have 3 numbers here, 3 numbers here. Let me make this a little bigger. So let me put my brackets in. And again, I'm just going to do this. So row 1, row 2, row 3, column 1, column 2, and column 3. Okay, so for the first row, first column. So for this entry here, again, I want to think about getting the rows from the first one or B. So this is my first row here, okay? And I'm going to start with this row, okay, times this column here because it's column 1, so this first column here. So let me just kind of mark this one off. So 1 times negative 2 is negative 2, plus you'd have 5 times 5, which is 25. If I sum those two amounts together, I'm going to get 23. So that's my first entry. So this is going to be 23, okay? And I'm just going to work through this first row. So I'm going to get this one and this one. And so I'm staying with this first row with B, okay? So that's why it's going to be highlighted. So I'm just going to go through this one first. So 1 times 0 is 0, plus 5 times 9 is 45. So that's going to be 45 here, okay? And then I'm going to move to this one, okay? So I'm going to do 1 times 1, which is 1, plus 5 times negative 5 is negative 25. This is going to be negative 24. So negative 24. So that top row is now done, okay? So what I'm going to do now, since I'm in row 2, I'm just going to move this down to row 2, okay? So let me erase this, and let me highlight this row 2 here. And we'll start out with this one. So we're going to do 2 times negative 2, which is negative 4. Plus, we're going to do negative 3 times 5, which is negative 15. So negative 4 plus negative 15 is going to be negative 19. And let me erase this, and let me erase this. And now we're going to move into this one. So we have 2 times 0, which is 0, plus negative 3 times 9, which is negative 27. This is going to give me negative 27 here. So let's erase this. We've got one more for this second row. So let me just circle this like this. 2 times 1 is 2, plus negative 3 times negative 5 is 15. So this would be 17 here. Okay, so we just have one more kind of row down here to fill in. So let me just highlight this now, and we'll go through them. So you basically only have to, this is a shortcut. If you see a 0 here, you know that when you did kind of this one, and this one, in each case, 0 times this, the top one, okay, is going to be 0. So really all I have to do is figure out what is 7 times 5, that's 35. Then what is 7 times 9, that's 63. And then what is 7 times negative 5, that's negative 35. Okay, that's a little shortcut. If you see things like that, always take that opportunity, because again, if I did this guy right here, it would be 0 times negative 2, which is 0, plus you'd have 7 times 5, which is 35. Okay, so I just shortcutted that process to get these numbers. All right, so we've found BA and we've already found AB. So we've got that result. So now let's move on and let's talk about what happens when you multiply two matrices together that are square matrices, okay, of the same order. So if you're multiplying a 2 by 2 and another 2 by 2, obviously you get a 2 by 2. If you multiply a 3 by 3 and another 3 by 3, you get a 3 by 3. If you multiply 117 by 117 and another 117 by 117, you get 117 by 117, okay? So it's very obvious that you will always be able to kind of do the multiplication, okay, when you have two square matrices being multiplied together and they're of the same order. So in this case, A, again, it's a 2 by 2, and B is also a 2 by 2. So these numbers here are going to be the same, and the outer numbers are going to be the same. So we know that the product here, AB, would just be a 2 by 2 matrix, okay? And so we'll just do this one more time. So this is row 1 and row 2. This is column 1 and column 2. So again, for row 1, to kind of find this guy right here, I go to the row 1 from A, the first one, okay? So this is my row 1 here. And for the column, I find it from here. So this is my column 1 here. So I take the product of this row times this column to find this guy right here. So 10 times negative 2 is negative 20. Plus we have 11 times 5, that's 55. 55 minus 20 would give me 35. And then what would I do next? Well, I want to move into this one. So same row up here, but different column over here, okay? So I would do 10 times 9, which is 90. Plus 11 times 7, which is 77. And if I do 90 plus 77, I'm going to get 167. Okay, so again, very, very easy. Now I'm moving into row 2 in column 1. So for row 2, again, it comes from the first one. So this is my row 2 here, and I want my column 1 here. I want the product of those two. So negative 3 times negative 2 is 6. Plus I'd have 1 times 5, which is 5. This gives me 11. And then I just move down 1. So I'm going to do this column here now. So when we look at this, we have negative 3 times 9, that's negative 27, plus 1 times 7, which is 7. Negative 27 plus 7 is negative 20, okay? So that's going to be my product AB. If you want to flip this around just for practice and do BA, okay? Again, it's going to be the same size, but the way that you calculate it's going to be different because B is now first. So if I think about the row 1, I've got to think about the row 1 from B. okay? So this guy right here, if I think about column 1, the column 1 is going to be for A, okay? So I want to find the product of this guy times this guy. So this row vector times this column vector. So negative 2 times 10 is negative 20. Then plus 9 times negative 3 is negative 27. Negative 20 plus negative 27 is going to be negative 47. Again, we just proceed. So now I'm going to kind of move to this column here, and I'm going to find the product of these two. So negative 2 times 11 is negative 22, and then plus 9 times 1, which is 9. So negative 22 plus 9 is going to give me negative 13. And now what I'm doing is I'm moving into row 2, okay? So I'm moving into row 2. Again, that's from the first one. So this guy right here, I'm in row 2, and I'm going to start with column 1 here. So row 2, column 1, 5 times 10 is 50, plus 7 times negative 3 is negative 21. 50 plus negative 21 is going to be 29. And then we just have one more to do. Again, I'm just going to shift this column here to this guy because I'm in column 2 now. So I'd have 5 times 11, which is 55, plus 1 times 7, which is 7. 55 plus 7 is going to give me 62, okay? So hopefully this is clear for you. This is something that you do need to practice quite a few times to have it down, okay? You'll develop your own method, your own strategy for doing this. But typically, I like to write out the row and the columns like I did in these examples here to keep track of where I need to be in my multiplication. I've found that a lot of students that struggle with this, if they just employ this kind of simple technique, they end up really being able to improve their result quite substantially.